Welcome CNC professionals to another exclusive webinar from Eurotech. My name is Larry Greenwald and I will be your presenter today on what is superimposition programming. Before we get started, just a reminder, to avoid feedback and background echo, please mute your microphones and be sure to adjust your volume to a comfortable level. At the end of this session, be sure to send questions and comments to me at eurotechelite.com or call me at 352-799-5223. Ready? Let's begin. Superimposition programming. This feature allows an axis to be superimposed and controlled with an axis by another workpiece program. In simpler terms, a selected axis in a second program moves simultaneous with the first program. So in other words, here we have the master axis, which is X1 or X2, or even in the case of the machine we're going to be talking about, the Rapido, also Y-axis. But for this, X1 and 2 we're going to use for superimposing with the slave axis, which in this case would be X3, Z3, which is our subspindle. The machine we will use for this example in this webinar will be the Rapido. This machine is 10 axis, has 2 turrets, 3 channels, and superimposition. Let's take a look at the axis configuration of the Rapido. So the Rapido with 2 turrets, you see 2 turrets here, and the upper turret, the turret up on top, is controlled by channel 1, a separate program, and on the lower turret is controlled by channel 2, and then on the subspindle is controlled by channel 3. So if you look at the axis on channel 1, starting on the upper left-hand corner here, we have X1, Y1, and Z1. Lower turret, the same, but we have X2, Y2, and Z2. And then on the subspindle moves in an X-axis configured manner, and also we have the Z, which moves to and from the main spindle. Here are 3 examples of using 3 tools in the cut. So in other words, 3 tools cutting at the same time. So let's look at the first example on the upper left. You see here we have a turning operation on the upper turret working simultaneous with a drilling operation that is programmed from the lower turret. And in superimposition mode, we are cutting or turning on the subspindle. So if you look at that closely, what you see is you see the lower turret equipped with a drill and a turning tool on the same holder. And while we're drilling on the main spindle, the subspindle is moving and turning in X and Z at the same time. That's superimposition. The second example on the upper right hand is simultaneous machining, right? With the upper turret turning, the lower turret turning, and on the lower turret, there's a drill mounted towards the subspindle. And while we are turning on channel 2, we are bringing channel 3 up to drill at the same time. The third example down below is a drill, a drill operation. So we have the drilling on the main spindle, a drilling on the subspindle at the same time, and then the upper turret is turning. Now these different operations can be roughing operations, they can be finishing operations. It's pretty amazing all the different things you can do with this type of superimposition programming. So let's look at some of the advantages of superimposition programming. Number one, 3 tools in the cut. Number 2, reduce cycle times by having 3 tools in the cut. Expanded tool use, meaning we can put more tools on the turrets doing simultaneous machining operations. Maximum material removal. I mean, when you're using 3 tools to cut this workpiece, whatever workpiece you're using, you are significantly moving more material at one time. And finally, increased profit. All right, how to make it work. First of all, the programming, very important. We need to understand and learn how to effectively program the workpiece. Number 2, we need a defined and well thought out setup of how we're going to configure our tool stations. And number 3, we always want to dry run this particular program to make sure that our timing and our weighting codes are in the proper place. Let's review again some programming examples. Drill on the main, drill on the sub, drill on the main, turn and bore on the sub, turn and bore on the main and drill on the sub, or turn, bore on the main and turn and bore on the sub. So these are just a few different configurations, popular configurations you can do with superimposition. So let's walk before we run. Here's superimposition using the Z-axis only. So for this example, what we're going to do is we're going to drill on the main spindle with the lower turret, channel 2, and on the back side of that holder, we're going to drill simultaneous with the subspindle. So it's important to realize and look at here is we have Z0 at the front of the part on the main spindle, Z0 on the front of the part on the subspindle, but we're using 2 different work coordinates, G54 for the main spindle, and remember this is all coming from channel 2, and a G55 for the subspindle. Next, let's look at the steps to correctly setting up superimposition for the part that is usually using the ZZ drilling. Number 1, the G54Z0 must be set up on channel 1, and the G55 position must be known, whether it's just a stick out length from the collet or an actual part reference. Number 2, we take that tool and touch off that tool with a probe as normal to establish its tool geometry offset. Number 3, bring that tool to Z0, the program Z0, right? And the tool does not have to necessarily be on center line. You know, it's a drill because we are only setting the Z-axis. This way, the tool doesn't actually have to be touching the material. Number 4, bring the subspindle, channel 3, to the T0101Z0. This is setting the geometry for that tool. Number 5, go to Setup page, make sure it's channel 3, and go to T measure, cursor to tool 1 under Z, and press work measure, then offset right. Note that the referencing, the picture up above, T0121 would be offset from channel 2 and the number 21 using the number 21 offset geometry. Then on tool 1 would be offset from channel 3 on the number 1 offset. Negative offset would push the drill deeper, and a positive offset would make the tool go the opposite direction or away from the part. Before we start the programming, let's look at the code itself for superimposition, which is G126. So the first one here, G126 Z3 equals Z2, says the Z3 moves will follow or superimpose with all the Z2 moves. So in other words, every time Z2 moves, Z3 will move in conjunction with it. Even though it's programmed to different depths, different feeds, different speeds, it will keep those two together as if they're tied in together. So every time Z2 moves, Z3 moves accordingly. Now the P is called a corrector. The corrector is the difference between the two axes. It's easier to kind of relate the x-axis because, for instance, the x-axis you may have, because of the actual tool position might be at different x centers or x0 values. So whatever that difference is going to be the corrector. Okay? So we have G126 where we could use Z3 equals Z1. So in other words, the Z3 follows all the Z1 moves. Or G126 X3 equal X2. So in other words, again, X3 will follow anything X2 does or moves. It will follow those moves because they're synchronized together. They're tied together. And then the last one here, G126 X3 equal X1. So again, channel 1. So if X1 moves and X3 is supposed to be synchronized with it, it moves with it. Now we have the actual programming using superimposition for our example doing a drill. We've defined this with 3 different sections. We have in red the header information, and that header information is nothing more than just the setup we need before we begin the superimposition. So some of this is setting up the G54, which would normally be at the beginning of the program, which is, so the pound 5222 that you see there, again in the left column for the upper turret, that's setting the G54. The 5222 is the work coordinate G54. It's a system variable. The 502 is the overall part length, and the pound 405 is the stick out from the main spindle collet. Now we have Rapido custom macros to use with this machine to make some of this a little bit simpler, and that's what you're seeing here. Some of these variables are just filling in the blanks for things. For instance, if you look in the second column, the part length 1.515, that's pound 403. Pound 405 is the stock stick out from the main, which is 2-inch. And then here we go again, pound 5222 is the G54 on the main. Let's look at, in the first column, go all the way about the middle of this page and see where you see G0, G28, U0. So what that operation was just above that is to face off the part in the main spindle. So it's tool 3, it's facing off the part. And then at the end of the face off, right, we have a exclamation 2, exclamation 3, L3, which is the waiting code to confirm that head 1, head 2, head 3 are all synced up and to begin the superimposition. So if we look at the second column, which is the lower turret program, if you look at the information that's in blue, that's just to get the tool ready. Now look above that in the header information, just above the blue section there, and you'll see a G126Z3, and then below that a G126X3. So that's actually canceling the superimposition before we call it up again, because we want to make sure that there's no previous superimposition that's active. So we want to kind of, as a little bit of an insurance policy, make sure that that is not active before we call it up. So then next we have a waiting code, and then below that we have where we're just positioning the drill to the main spindle. So that's tool 1, offset 21, positioning, it's at 0.5, right? So it's a ½ inch away from starting the drilling. And then it's going to sit there right under that M29 there. It's going to sit there with a exclamation 1, exclamation 3, L3, all right? Because it's going to wait until the face-off operation is finished. And if we look at the third column there for the subspindle, and let's look at the blue section, right? And there's really not much there as far as programming goes, other than just the waiting code, just making sure everything previously has been finished. And then what we're looking for is we're looking for that exclamation 1, exclamation 2, L3. So that when everybody gets to that same place in the program, in other words, they're all going to be synchronized, ready to go. So what do we have in column 1? Next, we have in column 1, we have exclamation 2, exclamation 3, L50. So actually the upper turret's going to sit there and really do nothing until the second channel is drilling, finished drilling, and the third channel is finished drilling. Again, this is a simple example of just using a drill. So let's look at column 2 again, and let's follow the programming a little bit. We have the G54, the drill moves into Z.1, right? 1500 RPM, M3, and we are now only communicating between the two channels, channel 2 and channel 3. So we only have, if you look below, down towards the bottom, we have an exclamation 3, L23, which is a wait command, because in the third program, you notice we have, and this is in the green now, if you look in the third column, we have the subspindle running at 2700 RPM. So we have two different RPMs, because we can't always make sure that we have just one RPM for two different size drills. Let's say we had a much larger drill in the main spindle drilling the main, but a much smaller drill drilling the sub, which is normally the case. So we have two different RPMs going, because we can, command the main spindle at 1 RPM. In this case, it was programmed at 1500 on the main for the drill that's drilling the main, and 2700 RPM for the subspindle. Then after the subspindle is rolling at 2700 RPM, we're going to tell it to move to X position, which is going to be a shifted position for clearance. Now that's only for clearance. And then Z1, right? And then the weighting code. And then shift back to the center program, the channel 2 program, lower turret, and look towards the bottom, and there is the superimposition that's being applied. So we have a G126 X3 equals Z2 with a P of pound 540 plus pound 450 plus 460, and then divide that by 2. Why is it divided by 2? Because we're looking for the radial distance between the two, the physical radial distance, because we're concerned here in superimposition. We are concerned not about the diameter for X. We are concerned about the actual physical movement that's going to show us in position on the position page. So we're going to divide that by 2, and that's going to give us that shifted value between those two, between the centers, between the X2 center where it's drilling in the X3 center. Okay, and then next we also have G126 Z3 equals Z2 with a P, and it says here minus pound 454 plus pound 455. And again, those values we can find on some on our macro custom macros. Next, let's look at, again in red, after the superimposition has been imposed. In red, we in the center column there, which is channel 2, you notice that we have go to X0, drill down 215 thousandths deep at 4 thousandths, back up, rapid to 0.1, return back to Z minus 0.275, and continue to drill down to Z minus 0.590, and then rapid back out to 0.1. And then a weighting code exclamation 3 L26. Now let's look over at channel 3, and we have sort of the same thing but different numbers. We have go to or rapid to X0, right? So that's the drill mounted on the backside. Drill in to Z minus 315. So now the subspindle now is moving over that drill. So as it's drilling in the main spindle, right? As it's drilling in the main spindle, the drill that's mounted on the opposite side, the subspindle, is moving up and going at 4 thousandths per rev, but it's following not only the Z-axis movement on the main, but it is independently drilling that Z minus 315 depth. And then it has a rapid back. Now, it doesn't matter whether you have these exactly timed together, because timing is not the issue. Once they are superimposed, they are tied together. So let's, for example, let's take a look at it. If we're moving exactly the same, if we are moving exactly the same distance on both, right? But one is going at 4 thou per rev at 1500 RPM, and the other is going 4 thou per rev at 2700 RPM, then the drill going at 2700 RPM is going to get to that Z minus 315 first. And then what's next? Rapid back. So it will, that subspindle will rapid back 100 thousandths away from its Z0 independently of what's going on the main spindle. It's sort of abstract, but the only thing to keep in mind is when that drill on the main spindle is drilling, for instance, if it was to move back, and when it does move back with its G0Z.1, they're both those slides are going to move at the same time and same rate in rapid back. So in other words, what's going to happen, I can tell you right now just by looking at the code, what's going to happen is the drill on the subspindle is going to finish before the drill on the main spindle. And the first rapid is going to happen on the subspindle, and the second rapid is going to happen on the main spindle. But regardless, it will still feed independently. Now next, once we are finished, right, we have a waiting code at the end. We have this after the drilling has been completed. We have a waiting code that's pound 3 L26, right? And we see it also in the channel 3 program L2 L26. It's just saying, those are the two channels that are in communication with each other. And then a G126 X3, G126 Z3, and you see that in both programs. So we have the canceling the synchronization in both programs. And once they're canceled, they're independent. Now we can continue on doing other items. Okay, here we go. Let's look at some superimposition in action. We did a face-off. We have a drill, and on the back side we're doing a rough turning, and on the upper turn we're doing a turning. Now we have a drilling on the main, drilling on the sub at the same time, and then a finish turning operation on the upper. All right, you can follow it along there. So now let's go and look again at that. There we go. Let's look at that drill. So what we have is, we go through here, we bring the drills into position, and you see that you can even do peck drilling. If you follow this along, depending, and then again, so there's a couple examples of 3 tools in the cut at one time. So to review the advantage of superimposition programming, number 1, 3 tools in the cut, reduced cycle times, expanded tool use, maximum material removal, and increased profits. Thank you for watching. I hope this presentation was of value to you. If there's anything we can help you with on your Eurotech machines, please don't hesitate to contact us. Thank you, and until next time, keep on turning.